Today is part 2 of what we are calling the AWS Reinvent Recap, which is a relook at what has been recently announced in AWS Reinvent, which happens November of every year. And around that time frame, what are the exciting new features and services or enhancements that have been announced. And today's focus will be on data and analytics services. And I am Raghuveer, and I'll be the host for this session today. And data analytics has seen a lot of focus, investment, and excitement in this time frame over the past few years. And we're only seeing an increasing pace of tools, adoption of tools, increased usage of tools, and a combination of tools in every use case. And AWS has been trying very hard to stay at the forefront of innovation in this space. And there have been a combination of enhancements to existing features like Glue, Lake Formation, Redshift across the board, as well as announcements of brand new features very recently. So in this session, we will focus mostly on new features that have been launched. We will probably find an alternate time to talk about enhancements on existing services as well. And among the services that were announced recently, Amazon DataZone seems to be the most exciting, for me personally at least. And that's where we will probably focus most of our time today on talking about. And we'll also touch upon a couple of other new services as well briefly. And in addition to that, like I said, there is going to be a quiz at the end of the session. Maybe we'll spend 15 to 20 minutes going through a fun quiz, and we'll give away some prizes at the end of it. So stay tuned. So we'll first talk about Amazon DataZone, which is the new product that was launched. So before we dive into any specifics of the product itself, let's talk briefly about the context in which that has come about. The fact of the matter is that over last many years, the importance of data or the strategic importance of data for any enterprise's success has only increased. The volume, variety, velocity of data has been exponentially increasing over the past few years, as you would have heard in many conversations that we have around data and data analytics in recent times. And that necessitated some amount of discipline, standardization, or what a lot of these big companies call modern data architecture, which brings together a lot of desirable traits and attributes of any good enterprise data architecture setup. So some of those elements are a scalable way of storing all types of data in one place, or a scalable data lake, whichever platform you choose, and services that are purpose built to address a particular type of data need, whether it is data science or machine learning, or business intelligence or dashboarding, or any other use case for that matter. Similarly, streaming ingestion, batch ingestion, and the processing of such data at high scale. Similarly, another attribute that is very desirable is having a unified layer of access and governance around that data, and then doing all this in a cost-effective and performant manner. So these are some of the attributes that are put together by various enterprises using the tools that they bring to market. So this is how AWS picturizes that space happening today with their purpose-built databases, serving a particular purpose around the periphery of a central data lake that is usually hosted on a S3 data lake, and then governed using something like AWS Lake Formation. And the access control over that is controlled through AWS Glue and the data catalog that is built by crawling that using AWS Glue. And that's the typical picture that AWS brings to market. There are other players in the market like Databricks, Snowflake, Azure, GCP, etc., that try to solve the problem in their own unique manner. Somebody like Databricks might come and say you don't need a different service or a different tool for BI versus machine learning. You can do it all as long as you have optimized your query engine to serve both use cases from the same underlying source of data, which is a data lake. So there are different approaches or schools of thought, and there is no right or wrong answer. It's up to us to make it work for a given customer scenario at scale. So in that context, we also tend to acknowledge and realize that when we deal with large enterprise customers, this modern data architecture is typically relevant not to the entire enterprise as a whole, but to a particular BU, domain, team, whatever you call it. They own their domain data, and they need this level of maturity in their data architecture to serve the needs of their BU. But the enterprise at large has multiple such domains, and each of them might have their own little domain, little or big, whatever, that owns the data, stores the data, process, and serves the data. And in that context is when the newer terms and buzzwords that you start hearing in the space, like data mesh, data fabric, etc., become relevant. So data mesh is a common term that we hear these days, and typically that is intended to bring together the various domains of such data that we talked about in the previous slide and make them work together collaboratively in a large enterprise context, and do so in a manner that the amount of friction or silos that appear naturally because of the way enterprises work are broken down, and the collaboration and access of data between producers and customers or consumers of data is made as seamless and frictionless as possible. So there are concepts like distributed ownership of data. So instead of forcing every owner of data to push their data into a central location and give up ownership of that data, we might encourage each owner of the data, each domain of the data to retain their ownership. So there is a distributed ownership of the data, and the kind of curation and stewardship that happens in each domain can vary from one domain to another. But we bring that together into a marketplace where producers and consumers of the data meet and are able to discover available data and use a mostly self-service architecture to also request access to that data and gain access to the data based on a unified layer of governance, which is typically federated in the sense that it's not a single team sitting at the center of things that controls access, but we let the owners of data decide some aspects of who can get access to data, how widely can my data be distributed. Similarly, the domain that is consuming the data will also have some scope of control in terms of within their teams, what are the roles and who should get what amount of access to the data that they have requested. So that is the context in which services like Amazon DataZone try to fill a gap or bring a competing service to somebody else that is already doing well in the market and address their business segment right? You have services like Snowflake, Databricks, and a few others who are already addressing some of this through their own unique means. And the way AWS has built their offerings so far, including ground level data storage and data processing and streaming batch and data transformation, data delivery, visualization, etc. It is at a very granular or grassroots level when we deal with data at a table, column, row, or individual record level. But there is a lot of gap between that and what a typical business user, business analyst, or a business leader understands data domains, and the exchange and collaboration of data that happens between teams. So there is some scope to bridge that gap through no code, low code interfaces or self-service interfaces, and that's where Amazon DataZone tries to fill a gap. So this is a brand new data management service that Amazon has announced very recently, and it is still in not even in preview. It is in a very limited gated preview right now. So you and me do not have direct access to the tool yet. We can request it and wait for it. And early 2023, this year, is when the preview will open to a wider audience, and then eventually it will become a product that we can all use. But there is some good amount of information available about what this service brings to the table and how it solves certain problems that we all typically see in this space. And it's useful to go through that to understand the thinking that went into creating this product, because maybe each one of us is probably solving one piece of this puzzle, if not the whole puzzle, for some of our customers. So some of the attributes of this service are already listed in this slide, but we will definitely touch upon those attributes as we go along on the subsequent slides as well. So I'll not spend more time here. At a logical or conceptual level, right? Amazon Data Zone is represented in the middle as a collection of capabilities in the orange box there. On the left side, you have all the data producers. And what you see here are representations of your typical data sources like S3, DynamoDB, or RDS that are all very, very familiar for us on an AWS native landscape. But you also have Amazon Airflow, which can give you connectivity to dozens, if not more, of third-party services of data. It could be SAP or any other source of data that you can do a bidirectional data connectivity to and bring that into the purview of Amazon DataZone. So that's the producer side, and it comes to DataZone's governance layer through the filter of Glue Data Catalog for all the data sources that Glue Data Catalog supports. And Amazon DataZone is also natively supporting Amazon Redshift, probably because Glue Data Catalog and Lake Formation today do not fully support Amazon Redshift natively. So on the right side, on the downstream side, you have the consumers of data. And at this time, Amazon DataZone allows these consumers of data to get subscribe to a published data set and query them through Amazon Athena or Redshift. And I'm sure a lot of API and other sources of integration are also on the cards. So as seen at the bottom, the governance is achieved through a combination of AWS Lake Formation for everything that Lake Formation supports natively, and there are direct integrations with Amazon Redshift for any data shares that need to happen through Redshift. So diving in slightly deeper, some of the core concepts that they have created to make this whole solution work are as follows. You have something called an organizational domain, and we will look at it from a slightly different angle in subsequent slides. But organizational domain, you can probably for now think of it as a department or a BU in a big enterprise organization, right? And within that organization domain, there might be a business data catalog that is generally the reference of all the data that they own and control. So there are definitions about the technical metadata about what tables and columns exist that contain various master and transactional data that the domain owns, as well as some business context and description around what the data means, right? Whether it is sales, revenue, customer data, or service data, what kind of data it is. And similarly, there is a concept called data projects, where within each domain, you might create a collection of people and assets to work on a particular problem. And typically, you want to address the needs of who should have access to what piece of data in the context of that project. So you may not want to grant access to a particular data set, for example, to person A, without any reference to why are we giving access to the person A to the table X, right? So you all the governance around who has access to what in Amazon DataZone is in the context of a data project. And if you remove the person from a project, any permissions granted to that person via that project automatically get removed. So that's the other concept. And yeah, and then there is a whole set of governance and access controls, and there is a workflow built to address how this will happen at this level of abstraction that we will go through in subsequent slides. In addition to these logical pieces, there are technical pieces of architecture, which is APIs that allow connectivity to third-party sources, or how you can tap into the capability of Amazon DataZone from any other enterprise tools that you have in the landscape. And then there is an actual data portal, which is its own web application outside the AWS console that that the enterprise customers of Amazon DataZone can all get access to. And any employee of that organization can log into this Amazon DataZone portal using federated identity like an Active Directory set of credentials, etc., and then get access to all these capabilities that this tool brings. So that's where some of that bridge between a technical data engineer who is working on AWS Glue or Redshift or EMR and doing SQL queries versus a business analyst or a business user who is not that familiar and hands-on with some of these tools is still able to interface with the data that is available and request access to that data, get access to that data, and directly query the data. So we will also see some screenshots and features of the portal in these slides. So this is at a glance to give you a picture of how the portal landing page would look like after you log in, right? So data catalog on the left navigation menu is one of the core elements of this portal, where anybody who logs in is able to explore the data, discover data, and determine whether the data that they need for a particular project is actually available, published by any domain owner. And similarly, you have multiple domains. We'll talk about domains and how they are related to each other in a subsequent slide. And then you can be part of multiple projects. And as you request data, access to data, you may have multiple data assets that you have access to that you can go through. And search is one of the main features of this portal, or powerful features of this portal, where as you type, the portal will give you results from various groups like data assets and the data catalog, based on any partial string search, etc. And it will give you some suggestions about which category might have more results related to your search string. And once you reach a search results page, there is a faceted search that lets you further slice and dice the search results and filter them down by domain or by data asset type, etc., so that you can narrow down your search and locate the data or information that you are looking for more quickly. And the concept of domains that we talked about is something that is at the core of Amazon DataZone, right? So a domain, like I said, can be thought of as related to a business unit or a department. So they have a particular way of dealing with data. They have a particular business glossary and definitions of terms, and they may have their own AWS account presence in any particular AWS region. And so the data sources and data assets that they own will be present typically in that AWS account, right? And there may be multiple such domains in the organization. And how this is made concrete is these domains, let's say there are a dozen different domains in a given organization, they can be logically put together in the form of a hierarchy at the enterprise level. So as shown in this example, there may be domains like sales, finance, and accounting. And there may be a hierarchy where the reporting domain may be a subset of the finance domain. So any governance applied will follow this hierarchy and trickle down this hierarchy. And at any level of this hierarchy, you can have an admin for the domain who broadly sets the rules of governance. And they can also delegate some permissions like a data steward who will be responsible for ensuring the quality of the data, enriching the data through metadata, augmentation, etc. Or they can control what kind of metadata is applicable for which data set in that domain, etc. That kind of delegation is possible through this hierarchy. So that's the view they have taken. And I think we covered this briefly in a previous slide, the various kinds of data sources that are possible to integrate through the Amazon DataZone service. Like I said, through a service like Amazon AppFlow, you might tap into data sources external to AWS. That could be Salesforce, Power BI, Snowflake, SAP, etc. Or I think there are 50 or even more AppFlow connectors today in the marketplace. Similarly, AWS Glue lets you crawl various sources of data beyond just your AWS RDS S3. You can tap into custom databases on-prem, etc., to bring those data into the Glue data catalog and thereby expose it through the DataZone. So with that, we will go to a little bit of granularity in terms of how these different things relate to each other in the hierarchy, right? In the extreme right, you have a data asset, which may be let's say a table in a database, or it could be a dashboard, or it could be a report, etc. And that asset will have some metadata describing it, what is its technical name, English language description, any schema if it is a table, etc. And then there can be some other metadata, like in this example, an identifier from the sales domain that tells any other process that is reading it what kind of data asset is it. In this case, it is a sales form, for example. And that sales form itself can be defined in a more detailed manner using a metadata form that says, for a sales form, for a data asset of the type sales form, these are the various attributes of metadata that should be, or that are strongly recommended to be supplied, right? And these are some things that the domain admin and the data steward define for their own domain. So this can vary from domain to domain. So in this example, we are looking at sales domain as an example. And some of the attributes of in that metadata form defined for the data asset type can have a business glossary attached with it. So in this example, if sales region is a mandatory attribute, it can be mapped to a business glossary of type regions. And we can also define what are the valid values that are acceptable for this metadata attribute by defining a business glossary for that field. So these are some of the things that are possible to define and administer at a domain level. And like I said, multiple domains can coexist in a hierarchy in an enterprise level. And all of those domains have the power to define how data should be described or stored for their domain. And anybody who wants to publish data to their domain should follow these basic guidelines in terms of maintaining metadata, classifying data assets, etc., before it can be put in a common catalog. And another logical concept we talked about is project. We will probably not spend too much time on it, but this is a quick picture of what a project brings together, right? You have your data assets and some management around those data assets. You have a few members, and you can manage the requests to join that project from those members under that umbrella. And then you have a profile for the project, which has a lot of settings around which AWS account or region is it associated with, what are some settings of each individual members, and what are the capabilities that this project can allow for its members, whether it is through Redshift or Athena, which are the two services that are deeply integrated at this time, or any services that may be integrated in the future. And these projects allow people to publish data to Amazon DataZone catalog, as you see on the right. And you can also subscribe to a data catalog as a project, right? So there are basically two broad types of projects. You can create projects with people in it and data assets in it as a publisher, where you come together to work on a data set and enrich it and make it ready for publication. Or you can create a project as a collection of people and assets who will work on consuming the data and delivering some value. It could be a machine learning project or a dashboard or something else, or some sort of analysis. You could subscribe to a data set, and that subscription will be associated with the project that you have created on the consumer side. So with that, in a simple journey, a data consumer would come to the DataZone portal, and they would create a DataZone project in it. And then once they get access to the desired data, they can use tools like Athena or Redshift to query the data that they have gotten access to. And typically, there are three broad processes that happen here to make all this possible, right? There is a process to publish data to the DataZone, to a particular domain in DataZone. There is a process that people can follow to consume data, discover and subscribe that data. And once subscription is approved, there is a process to get the data from the source to the customer, which is the fulfillment process. So once again, we'll probably skim through it in the interest of time, but there is a stepwise process through which the publishing project team can go through identifying the data, enriching that data, making sure that the right kind of metadata as dictated by their domain is actually available, and then make it ready for publication. And then they submit it for publication, and the data steward of the domain can review and either approve or reject that, or go through an iterative process of enrichment of the metadata to make it fit for publication. At the end of it, it gets published. So one cool feature that Amazon has come up with here is when you have tons and tons of tables and data, right? It's not always manually possible or practical to provide business glossary or English language names for each column or table, etc. So Amazon has gone ahead and trained a machine learning model to come up with those names automatically. So it will suggest what could be a good name for a given technical name from a table, and you can either accept it or override it with a manual entry. So this should make the life of the data publishers very easy when they are making their data ready for publication. Similarly, on the subscribing side, somebody who wants to discover data and consume data would go to the DataZone portal and go through the data catalog, either browse through it or search for it. And once they locate a particular piece of information, there is a lot of rich metadata around that data set that will give them enough insight to determine whether it is good enough for them. and then they will go ahead and put a subscription request against that, and it can be rejected or approved by the corresponding owners of the data. And once the subscription is granted, that's when the fulfillment process takes over, and then the subscriber will get notified when the fulfillment has happened. Fulfillment can take a couple of different forms depending on the actual data we are talking about. So in the case of, let's say, glue table that is being shared between account A and account B, they need not be in the same account, they need not be in the same region. And all the heavy lifting that is there today in terms of making this data sharing possible through even a service like Lake Formation is simplified by using Amazon DataZone, because the process of creating the correct data share from the producer account and then accepting it from the consumer account and then delegating the permissions to the right user as a lake formation admin on the consumer side, all of that gets simplified and automated behind the scenes. So as part of this fulfillment workflow. So yeah, if you have played with lake formation and seen that it is powerful, that it gives you a lot of fine-grained control from a single place in terms of granting permissions to a particular user on a particular table, restricted by a particular column or filter, right? All that is still possible, but the amount of hard work required in actually doing all that will be slightly reduced, slightly or greatly reduced through the automation that Amazon DataZone layers on top of this. Similarly, if you're talking about Redshift as the source of data, in the previous slide, there is no actual movement of data. Data is directly shared across those accounts. Whereas if you're talking about Redshift, the current state of the art is that you need to be running an Amazon Redshift cluster in the consuming account as well in order to receive a Redshift data share. So again, there is a lot of heavy lifting in terms of creating a Redshift data share, and there is a newly launched feature where lake formation allows you to control Redshift data share permissions across two accounts, but still it requires a lot of steps on the producer side as well as the consumer side. If you go through the native AWS console experience of Redshift Resource Access Manager and lake formation, and all of that gets simplified to a great extent if you use Amazon DataZone to automate that workflow. And if it so happens that both the producer and consumer are actually in the same AWS account, instead of doing the Redshift data share and cross-account grants, the workflow will intelligently decide to implement a direct grant on the same Redshift cluster instead of doing a cross-account grant. So that's some of the heavy lifting that Amazon is trying to simplify here. So in conclusion, overall, the problem that Amazon is trying to solve is that of the data silos that naturally form in large organizations where there are different domains of data, different consumers and producers, often separated by a lot of bureaucracy and red tape. And this portal is supposed to make that journey seamless and collaboration more easy, right? So you might have worked on similar problems in your projects or in your past experience. We are currently solving the exact same problem for one of our flagship customers too, and we are actually building a custom solution and enhancing it to bring some of these very aspects into that custom solution. So we are excited to see what Amazon brings to the table, how their solution differs from ours, and yeah, but one of the features that they talked about, and I forgot to mention that, is something called deep links into the Amazon console, right? So once you receive a data share, if you want to use Athena to query the tables that you just requested access to and got access to, you don't have to separately make the journey of going to the AWS console and navigating to Athena and then finding that table in the catalog and then issuing a query against it. There will in your view of the data portal, there will be a link in the fulfilled subscription against that data set, where which clicking on that link will directly take you to the Athena console with that corresponding database schema and table in context, right? So you can directly jump into querying that table straight away without having to lose context and do context switching. So that seems something that somebody like Amazon can only bring to the table, not a custom solution can solve, right? So those are some of the things that excite me. And yeah, hopefully this you found that interesting as well. So yeah, so I think we already spent half an hour on topic one. So like I said, we'll briefly spend On the other two new services that were launched in the data analytics space, we will not go into the same level of detail. I only have a single slide for each. So here, AWS Clean Rooms is another service that was launched, and the main problem that this service tries to solve is sharing of data outside the enterprise. So far, we talked about within the enterprise how you can make collaboration and data sharing easier through a data mesh architecture, etc. But in a lot of scenarios, there is a common use case where you need to share data with your vendors, partners, suppliers, marketing or advertising partners, etc. But there is a lot of risk associated with giving your customer data or other confidential data to these partners without knowing how securely they will handle the data outside your purview and control. At the same time, if you do not share the data with those partners, there is very limited value that they can bring to the table. A good example is if you are partnering with a firm that helps you do targeted marketing communications to your consumer segments, like I want to advertise my services based on an age group, demography, location, gender, etc. You probably don't have in-house tools or expertise to do that level of customer segmentation and marketing. So you may go and partner with a digital marketing agency that will say, okay, give me your current customer segments or people who have reached out to you or various channels, which are your potential customer database. And then I will help you segment that data and maybe do some mapping of their profiles, maybe target them through the various communication channels that we have, and provide a personalized or customized marketing or promotion message to those segments, right? So if you want to do that kind of outreach exercise without sharing data with your partner, it won't go anywhere. And if you share your customer data, there is a lot of privacy concerns and confidentiality concerns that you will have to deal with. So clean rooms is a concept where you are able to do data sharing and collaboration without actually transferring data into an external system. At the same time, you're also able to put very strict controls on what kind of analysis can be done on that data or what fields of data can be read, etc. So one interesting aspect of this is when you create a clean room and create a data share with a partner team, you create a data set and make that available through that Amazon clean room that you create, right? You can put a restriction on the kind of analysis that can be done or the kind of queries that can be done. You can say people can query this table only when they join it with another table. You cannot directly query records in this table, for example. Or you can say if you're running an aggregate query on this table, return results only if it summarizes at least, let's say, 100 records or 200 records. Why is that important, right? If you have seen some of the recent commentary on the kind of precise profiling that happens on Facebook or the Cambridge Analytica case, etc., right? The kind of precise personalized targeting that was possible on a platform like Facebook is because the sheer number of dimensions that you are able to collect about a particular individual allows you to slice and dice the whole data, even if it is anonymized. Even if I remove the name, address, gender, and everything that is directly identifiable from the data set, I can still construct a query with narrow filters to pinpoint a particular person that I know in a large anonymized data set. If I say, give me everybody who is between 40 and 45 years of age, residing in this zip code or pin code that matches these 2, 3 criteria, right? I'll probably narrow it down to 5, 6, or even one individual, even in a data set of 1 million. So that's the kind of risk that is eliminated by putting these kind of controls, saying any aggregate queries or other queries can return results only if the aggregate data at least at this level of granularity. So those are the kind of controls that AWS Clean Rooms provides, and some of the larger enterprise customers that have collaborations across their vendors, and these kind of relationships where huge data sets that are sensitive, confidential, need to be shared for a genuine business case can benefit from this new service. So that's about AWS Clean Rooms. Oops. All right. The other service that we'll briefly talk about is Amazon Security Lake. So data lake, we are all probably familiar with. It's a collection of all types of data to serve all types of use cases. But there is definitely scope. I mean, a data lake by itself is a generic concept that it can serve all types of data in terms, irrespective of which business domain it belongs to or which industry it belongs to. But each domain or industry may have some unique needs with respect to the data that it handles. That there is a scope to bring some specific tooling, processing, and frameworks to solve that domain's problem. So you may have heard about Amazon Health Lake. You may have heard about Amazon Telco Lake. These are some solutions that Amazon has launched in the past to solve domain-specific problems in those respective domains, right? Similarly, Amazon Security Lake, as the name implies, is something that Amazon has put together to solve problem in the specific space of security. When we say security, we're more specifically talking about pulling in data in terms of security and audit logs from various different sources, whether it is AWS native sources like CloudWatch, CloudTrail, etc., or it could be external sources from commercial third-party tools on-prem or on cloud, and bringing that all into one place and normalizing the data formats in a way that lends itself to analysis across the board, and then connecting it seamlessly to analysis and visualization tools like your QuickSight and Power BI. So one of the core differentiators that this product brings is the normalization of the data formats across the board. They went out and collaborated with the big shots in the industry like Splunk and a few other security leaders, right? And created an open source foundation called the OCSF, or the Open Cyber Security Schema Framework, which is the schema to define how a security audit log should look like, right? With all the right pieces of metadata at the right granularity. And they are using that open source schema to normalize all data that comes in from any source, and then store it in that format so that any querying that you do can benefit from that normalized schema. So that's one of the core features of Security Lake. And yeah, but there are a few other features that might interest you if you are keen in this space, right? I'll probably post some links to blog posts and YouTube videos that go into a bit of detail about this. So that's the other service that is in preview at this time, and hopefully sometime later this year we will see it generally available across all AWS regions. So that brings us to the end of the agenda for today. I think we are 20 minutes from 4 o'clock. So we'll probably spend 5 minutes if you have any questions about the topics that we covered today, and then we move on to the fun stuff. Please feel free to unmute yourself, ask any questions that you have, or share any perspective that you have on these topics.